In the vastness of the cosmos, a magnificent ballet unfolds, a cosmic dance that weaves together the very fabric of existence. Among the myriad wonders of the universe, few phenomena capture the imagination like nebulae and supernovae. These celestial entities are not merely objects to observe. They are integral players in the grand narrative of creation and destruction, of birth and death. Imagine standing on a distant planet, gazing up at a nebula, a billowing cloud of gas and dust, illuminated by the light of newborn stars. This stunning vista is a testament to the intricate interplay of stellar evolution. Nebulae serve as the stellar nurseries where new stars are born. Fragments of former stars or raw cosmic material coalescing into brilliant orbs of nuclear fusion. Yet, as we marvel at this beauty, we must also acknowledge the transient nature of these clouds of gas. Supernovae, the explosive deaths of massive stars, play a pivotal role in the life cycle of the universe. When a star exhausts its nuclear fuel, it reaches a critical point, igniting a spectacular reaction that can outshine entire galaxies for a brief moment. This cataclysmic event is not just an end, it is a powerful beginning. As the star erupts, it sends shockwaves through space, scattering its elemental components in all directions. Hydrogen, helium, carbon, and more complex elements forged in the star's core. These elements, once confined to a solitary star, are now liberated into the galaxy, embarking on a journey that will contribute to the creation of new stars, planets, and even the building blocks of life as we know it. To understand the magnitude of this process, contemplate this. Every heavy element in your body, from the iron in your blood to the calcium in your bones, can trace its origins back to the heart of a dying star. The spectrum of elements released during a supernova is astonishing. A single supernova can eject enough material to create dozens of new stars, forming regions teeming with potential. Within millions of years, these elemental clouds collapse under their own gravity, leading to the creation of massive new stars, effectively handing over the reins of the cosmic cycle. Each explosion seeds the galaxy with rich materials and forms a tapestry of interconnected stars and planets, all birthed from the ashes of what once was. Picture the intricate ballet of energy and matter as it unfolds. Nebulae become the canvas upon which new stars paint their luminous tales. These stellar creations, the offspring of supernovae, engage in their own life cycles, impacting the environment around them, enriching the interstellar medium with freshly synthesized elements. This establishes a cosmic feedback loop where stars give rise to nebulae, and in turn, supernovae send forth the very elements that will fuel future generations of stars. The aftermath of a supernova is as captivating as the explosion itself. What remains can vary widely: a neutron star or a black hole, both remnants of colossal forces. The energy produced in the core of a massive star, when compressed, can lead to a neutron star with a density so extreme that a teaspoon of its material would weigh about as much as an elephant on Earth. Alternatively, the collapse may result in a black hole, an enigmatic point in space where the gravitational pull is so strong that not even light can escape. Realize how each of these end states contributes to the cosmic dance. The elements are not merely diffused into the void, but instead swirl and mingle in the expansive galaxies, creating new possibilities. Every star you see twinkling in the night sky is a continuation of this cycle, a beacon lit by the remnants of previous epochs. As we venture further into the realms of nebulae and supernovae, we will unearth their compelling narratives, revealing how they are not isolated phenomena, but rather intertwined chapters in the universal story, showcasing the ongoing interplay between creation and destruction. The dance that originated with the Big Bang continues to evolve, resonating across the cosmos, where even the remnants of the past find new purposes in the birth of stars. So, let us surrender ourselves to this cosmic spectacle, where the mysteries of nebulae and supernovae await, inviting us to explore the profound connections between these awe-inspiring phenomena. Each heartbeat reverberates through the vast stretches of time and space, a gentle reminder of our shared origin with the stars, urging us to keep listening and learning amidst the grand orchestration of the universe. In the vast expanse of the universe, nebulae serve as some of the most intriguing phenomena, acting as the cosmic cradle of star formation. But what exactly are these beautiful, colorful clouds of gas and dust? At their core, nebulae are composed primarily of hydrogen, along with other gases and dust particles. This combination creates a rich, dense environment where the seeds of new stars can take root. Picture a splendid cloud, appearing like a watercolor painting in the night sky, with hints of pinks, blues, and greens. These colors are produced by the elements within them, illuminated by energetic processes occurring in and around these enormous clouds. Nebulae can be categorized into several types, with the most prominent being emission nebulae, reflection nebulae, and dark nebulae. Emission nebulae, like the Orion Nebula, are regions where new stars are actively forming. The intense radiation emitted by these newborn stars ionizes the surrounding gas, causing it to glow brilliantly. In contrast, reflection nebulae do not emit their own light, but instead reflect the light of nearby stars. They appear bluish in color because blue light is scattered more effectively than red light. Dark nebulae, on the other hand, are dense concentrations of gas and dust that block the light of objects behind them, appearing as dark patches against the backdrop of brighter stars. The process of nebula formation begins with the gravitational collapse of certain regions within giant molecular clouds. These clouds can span across light years, harboring enough mass to potentially birth thousands of stars. As regions within the cloud begin to collapse under their own gravity, they condense and heat up. During this phase, protostars form at the center, and the surrounding material continues to rotate and flatten into a disk, a precursor to the formation of planetary systems. As these protostars evolve, they become more energetic, reaching temperatures hot enough to ignite nuclear fusion. This pivotal moment marks the birth of a new star, sending shockwaves of energy through the surrounding nebula. The interplay between light and gas creates an exquisite spectacle that we witness across the cosmos. The surroundings become illuminated, giving rise to bright emission nebulae, filled with vibrant colors as the star's energy disperses throughout the cloud, triggering the formation of new stars and planets nearby. Nebulae are also integral to the life cycle of galaxies. When stars reach the end of their lifetimes, especially massive ones, they undergo supernova explosions, an exhilarating yet violent release of energy. These cataclysmic events scatter the material that once formed the star into the surrounding space, enriching the interstellar medium with heavy elements like carbon, oxygen, and iron. The remnants of these supernovae can eventually merge with the material found in nebulae, creating a fertile environment for a new generation of stars and planets to emerge. One of the most famous nebulae in our own Milky Way, the Carina Nebula, showcases the complex beauty of these cosmic nurseries. Home to some of the brightest and most massive stars in our galaxy, it is a prime example of the awe-inspiring processes that take place within a nebula. Observations show that within the Carina Nebula, regions of intense star formation create a dynamic landscape where new stars rapidly evolve, fueled by the very elements scattered by previous generations of stars. Moreover, nebulae are not just isolated regions. They shape and influence the larger structure of galaxies. Their presence can create regions of higher star density in certain areas, leading to the formation of clusters of stars. This clustering plays a crucial role in the development of galactic features over time. As we explore nebulae, we also reveal secrets about the history and evolution of our universe. Each nebula acts as a time capsule, revealing the conditions and events that have shaped our cosmic neighborhood over billions of years. The study of these mesmerizing formations provides insights into the processes of star birth and the distribution of elements essential for life. In essence, nebulae represent a beautiful paradox of creation and transformation. They are both the canvas on which the universe paints its cosmic art and the wombs where stars are born. As we continue our journey through the cosmos, the beauty and significance of nebulae remind us of our own connection to the stars, ever reminding us that we are all composed of the same elements forged in the hearts of stars. To fully appreciate the cosmic artistry of supernovae, we first need to understand what they are and how they unfold. A supernova is not just a simple explosion. It is the spectacular end of a star's life cycle, occurring when a star exhausts its nuclear fuel. This process leads to a cataclysmic release of energy that can outshine entire galaxies for a brief moment in time. The forces at play during a supernova are immense, resulting in shock waves that ripple through space, carrying with them the remnants of the star and scattering vital elements far and wide. Supernovae can be categorized into two primary types, Type I and Type II. Type I supernovae occur in binary systems, where a white dwarf star siphons material from its companion. As the white dwarf accumulates mass and approaches a critical limit known as the Chandrasekhar limit, it ignites a runaway nuclear reaction. This sudden surge in energy leads to a swift and violent explosion, obliterating the white dwarf and releasing an impressive bounty of elements like carbon, oxygen, and iron. These elements are crucial for the formation of new stars, planets, and even life itself, effectively recycling material across the cosmos. On the other hand, Type II supernovae originate from massive stars, those at least 8 times the mass of our Sun. Throughout their lives, these stars burn through a succession of nuclear fuels, creating heavier elements in their cores. Eventually, when they can no longer sustain the nuclear fusion that supports them against gravitational collapse, their cores implode. This collapse is both swift and powerful, followed by an outer layer rebound and a shock wave that propels the outer material into space. The energy released during a Type II supernova can be astounding, sometimes releasing as much energy in a few seconds as our Sun will emit over its entire lifespan. Both types of supernovae are crucial in enriching the interstellar medium with heavy elements. They act as cosmic forges, generating and dispersing materials that are vital for the formation of new stars and planetary systems. For instance, elements like iron, which are forged in the guts of these exploding stars, are not only tools for astronomers to understand the universe, but also building blocks for planets, including Earth. When we observe the night sky and gaze upon the stars, we are looking at the remnants of elements that have traveled through time and space, echoing the stories of long-gone stellar giants. As we contemplate the sheer force of a supernova, it becomes clearer how these explosive events are intertwined with the very fabric of our universe. They are the climactic moments in the life cycle of stars, yet they give way to the birth of new systems. The material ejected from these explosions adds to the surrounding nebulae, seeding them with essential elements necessary for star formation. In essence, supernovae contribute to the ongoing narrative of cosmic evolution, illustrating a remarkable process where destruction ultimately leads to creation. Interestingly, the light from supernovae allows astronomers to study the expansion of the universe itself. The brightness of these explosions serves as a cosmic beacon, enabling scientists to measure distances across the vastness of space. Type Ia supernovae in particular have provided key evidence for the accelerated expansion of the universe, leading to groundbreaking discoveries regarding dark energy, a mysterious force thought to be driving this phenomenon. In summary, supernovae are not mere cosmic fireworks. They represent a complex interplay of astrophysical processes, from the immense forces driving the catastrophic end of massive stars to their role in distributing heavy elements across galaxies. Understanding supernovae opens a window into the universe's grand design. Each explosive event signifies both an ending and a new beginning, reminding us that amidst the brilliance of creation lies the inevitability of fate. A harmony of destruction and rebirth that resonates throughout the cosmos. As we continue this journey into the universe's depths, we will explore how these supernova remnants evolve into nebulae, the very cradles of new stars. So allow yourself to reflect on the cosmic connections we share with these stellar phenomena, rooted in the very elements that flow through our veins. With each passing moment, the universe unfolds its stories, waiting for us to listen and learn from the explosive epilogues of stars long gone. To understand the elemental composition of stars, we first need to explore the fundamental building blocks of matter that make up not only the stars, but our very existence. Stars are primarily composed of hydrogen and helium, the two simplest and lightest elements in the universe. In fact, approximately 74% of the mass of the universe is hydrogen, while about 24% is helium. These elements were formed during the Big Bang, laying the groundwork for the universe as we know it. Deep within the cores of stars, a powerful process known as nuclear fusion takes place. In this remarkable phenomenon, hydrogen atoms collide at immense pressures and temperatures, fusing together to create helium. During this fusion process, energy is released in the form of light and heat, which is why stars shine so brightly. This energy not only illuminates the cosmos, but also provides the conditions necessary for life to thrive on planets like Earth. As stars go through their life cycles, the composition of elements within them evolves. When a star exhausts its hydrogen fuel, it begins fusing helium into even heavier elements. This process continues, allowing stars to create essential elements like carbon, oxygen, and nitrogen, the very building blocks of life as we recognize it. Through a series of complex nuclear reactions, stars slowly assemble increasingly heavy elements through stages, ultimately culminating in the formation of iron. Iron, while being the heaviest element that can be formed through fusion in a star's core, signals a turning point in a star's life. When the core becomes predominantly iron, fusion ceases to yield energy, leading to a collapse of the core under its own weight. This catastrophic implosion sets the stage for one of the universe's most spectacular events, a supernova. In these extraordinary explosions, the outer layers of the star are violently expelled into space, resulting in an incredibly bright flash that can outshine an entire galaxy. This is when the true wonder of supernovae reveals itself. As the star erupts, it not only marks the end of its own life cycle, but also serves as a powerful forge for creating heavier elements, including gold, silver, and uranium. The immense heat and pressure of a supernova enable these transmutation processes to occur, crafting elements that were once merely a theoretical concept in the minds of early astronomers. The supernova explosion disperses these newly formed elements into the vast expanse of space, enriching the interstellar medium and making them available for future generations of stars and planets. Imagine this cosmic recycling process. As the remnants of a supernova scatter across the universe, the elements born from this celestial explosion mix with the gases and dust of other nebulae. This mixture acts as raw material for forming new stars, which will then repeat the cycle of fusion. It's as if each star is linked by a grand tapestry of elemental creation, sharing a deep and profound connection across time and space. Furthermore, The elements forged in the cores of stars and during supernova explosions are vital for the formation of planets. Without these cosmic processes, essential ingredients for life, such as carbon, oxygen, and iron, would be scarce or non-existent. Thus, we owe our very existence to the cycles of stellar evolution, where long-forgotten stars have contributed to the chemistry of our own solar system. As we gaze up at the night sky, we are not only looking at the stars, but we are witnessing the legacy of countless supernovae. Each twinkling light tells a story of a star that burned bright, transformed its core, and ultimately contributed to the fabric of life itself. It's a mesmerizing reminder of our common origin with these distant celestial companions, underscoring the idea that the atoms in our bodies were once nestled deep within the hearts of stars. In summary, the elemental composition of stars is a testament to the intricate processes of nuclear fusion and the extraordinary transformations that occur during their life cycles. The journey from simple hydrogen and helium to the rich tapestry of elements essential for life illustrates the profound interconnectedness of the universe. Stars and supernovae are not merely entities of the cosmos. They are the architects of the playground we call home, revealing that we all are made of stardust and forever linked to the vast universe around us. Within the grand tapestry of the universe, supernovae stand out not only as colossal explosions marking the end of a star's life, but also as powerful elemental factories. When massive stars exhaust their nuclear fuel, they reach a tipping point. The core collapses under gravity, resulting in a spectacular release of energy that can outshine entire galaxies for a brief moment. This cataclysmic event is not merely a farewell to the star. It is a crucial process that creates and disseminates some of the heaviest elements in our universe. During the life cycle of a massive star, nuclear fusion occurs in its core, creating lighter elements such as hydrogen and helium. As the star ages and the core contracts, it becomes hot enough for heavier elements to begin forming. These include carbon, oxygen, and eventually iron. The process unfolds like an intricate dance, each stage producing different elements which are embedded within the star's structure. However, when iron is formed, the star can no longer generate energy through fusion, leading to a dramatic collapse that culminates in a supernova explosion. In these extraordinary moments, conditions become extreme. Temperatures soar to hundreds of billions of degrees, and energy is released on a scale that is difficult to comprehend. During this stellar explosion, the outer layers of the star are ejected into space, carrying with them all the elements that were synthesized within. It is said that a single supernova can distribute enough heavy elements to enrich the surrounding interstellar medium, creating a new playground for future stars and planetary systems. To illustrate the significance of supernovae as elemental factories, consider this. The iron in your blood, the carbon in your cells, and the oxygen you breathe are all products of ancient stars that exploded long before our planet existed. Scientists estimate that supernovae are responsible for about half of the iron found in the universe. Without these immense cosmic events taking place over billions of years, the chemical richness so vital to life as we know it would be greatly diminished. The elements expelled by supernovae eventually blend into the clouds of gas and dust that form nebulae. These clouds become the raw materials for new stars and planets. Thus, we find ourselves in a perpetual cycle. Supernovae create the heavy elements that give rise to new stars and solar systems, which in turn can potentially harbor life. This cyclical nature of creation and destruction enforces the idea that we are all made from stardust. Additionally, it's fascinating to note that not all supernovae are created equal. There are two primary types, Type I supernovae and Type II supernovae, each playing unique roles in the cosmic factory. Type I supernovae occur in binary systems, where a white dwarf star accumulates matter from its partner until it reaches a critical mass, subsequently exploding. Type 2 supernovae, on the other hand, arise from singular massive stars. Both types contribute to the spread of elements, but the specifics of their explosions and outcomes differ, painting a rich portrait of stellar evolution. Supernova remnants are also critical to our understanding of the universe. The expanding shock waves from these explosions create a fertile environment where new stars can form, enriching the gases in these regions with heavy elements. This is often observed in the stunning images from our most powerful telescopes, where colorful remnants of past supernovae can be seen illuminating the dark canvas of space. Even the cosmic microwave background radiation, a relic of the early universe, carries signatures of the first elements that formed after the Big Bang. As these original elements traveled through interstellar space, supernovae helped forge new compounds, bringing about the diversity of elements we observe today. The connections between supernovae and the formation of elements reveal a deeply interconnected universe. The sheer scale and beauty of supernovae remind us how small yet significant our existence is. The elements that nourish our bodies are the product of billions of years of stellar evolution and violent explosions. These cosmic events are not just distant phenomena. They symbolize the intricate and dynamic processes that shape our universe and give rise to life itself. In conclusion, the vital role of supernovae as element factories highlights the relationship between destruction and creation within the cosmos. With every explosion, they scatter the building blocks of planets, stars, and even life across the universe, illustrating an intricate balletic cycle that resonates through time and space. Each supernova reinforces the profound connections we share with the cosmos, every atom in our bodies telling a story of stars long gone. As we gaze into the night sky, we can celebrate the fact that we carry within us the echoes of ancient supernovae, binding us to the stars in an eternal embrace. To understand the role of supernovae in distributing cosmic elements throughout the universe, we first need to explore the life cycle of a star. Stars begin their journey as vast clouds of dust and gas within nebulae, the stellar nurseries of the cosmos. These clouds, composed primarily of hydrogen and helium, are the building blocks of the universe. Over millions of years, gravitational forces begin to pull these particles together, leading to the formation of a protostar. As the protostar contracts, it heats up due to the immense pressure at its core. When temperatures soar high enough, nuclear fusion ignites and hydrogen atoms begin to fuse into helium, releasing an extraordinary amount of energy. This moment signals the birth of a main sequence star, which is a stable phase that can last billions of years, depending on the star's mass. Our own sun, for instance, has been in this stable phase for about 4.6 billion years and is expected to continue for another 5 billion years. As stars age, their cores undergo changes. In stars like the sun, once the hydrogen fuel is exhausted, the core contracts while the outer layers expand, transforming the star into a red giant. During this phase, helium begins to fuse into heavier elements, like carbon and oxygen. However, the life cycle of massive stars takes a different trajectory. For these giants, the process continues beyond helium fusion, forming even heavier elements deep within their cores through a series of nuclear fusion reactions. When a massive star exhausts its nuclear fuel, it can no longer support itself against gravitational collapse. The core, now composed of iron, cannot generate energy through fusion. This leads to an inability to counteract the force of gravity, causing the core to collapse in on itself. This calamitous event unleashes a series of reactions, triggering a spectacular explosion known as a supernova. Supernovae are among the most energetic events in the universe, radiating more energy in a few seconds than the sun will emit over its entire lifetime. The shock wave generated from this explosion is powerful enough to blow the star's outer layers into space, scattering essential elements forged in the heart of the star, such as carbon, nitrogen, and oxygen, into the universe. This bounty contributes significantly to the composition of the interstellar medium, enriching the very materials from which new stars will eventually form. The remnants of a supernova can also trigger the creation of new stars and even planets. The shock waves can compress nearby gas clouds, increasing the density and temperature necessary for star formation. In this way, supernovae act as cosmic agents of renewal, sowing the seeds of new celestial bodies across the universe. Despite the colossal forces at play, the remnants of these cataclysmic events can create stunning beauty. The Crab Nebula, a remnant of a supernova observed in 1054 AD, illustrates this vividly. Stretching over 11 light-years across, its colorful filaments are composed of elements that were once the very building blocks of the star itself, now transformed into glowing clouds of gas and dust. The cycle of stellar life, leading to supernovae and the subsequent dispersal of materials, reveals a profound truth about our universe. We are all made of star stuff. The carbon in our bodies, the oxygen we breathe, and the iron in our blood are a direct result of the cosmic processes ignited by these mighty explosions. As we gaze up at the night sky, we might be witnessing stars in their prime, on the verge of their own cosmic transformations. In an infinite dance of creation and destruction, the life cycle of a star, marked by the explosive grandeur of supernovae, reminds us of our deep interconnection with the cosmos, a poetic echo of life amidst the stars. In conclusion, as stars are born, live, and die, they weave a complex tapestry that enriches the universe, making it a dynamic place of endless possibility. This cycle not only illustrates the breathtaking processes at work in the cosmos, but also underscores our intrinsic relationship with the very essence of the universe itself. As we delve deeper into the cosmic recycling process, we find ourselves in the enchanting realm where supernovae serve as the catalysts for new creation. When a massive star reaches the end of its life, it triggers a supernova, an astronomical event of unparalleled intensity. This explosive death not only marks the end of the star, but also serves a far greater purpose. It disseminates an array of crucial elements throughout the surrounding cosmos. These elements include carbon, nitrogen, oxygen, and even heavier metals like iron, building blocks of life itself. Each supernova acts as a celestial barbecue, scattering these elements like seeds in a cosmic garden, primed for new growth. Following this dramatic event, the remnants of the supernova form what we affectionately term a supernova remnant. Initially, these remnants are hot and diffuse, glowing with the residual energy of the explosion. But over time, as the remnants expand and cool, they become potential nurseries for new nebulae, regions where gas and dust can coalesce over millions of years. Herein lies the fascinating link between destruction and rebirth. The remnants of a star's death enrich the interstellar medium with heavy elements, paving the way for new generations of stars. Let us envision the vast stretches of space, teeming with swirling clouds of gas and dust left in the wake of a supernova. These clouds, infused with metals and complex molecules, provide the essential material for nebulae to flourish. As gravity works its magic, it draws together the material in these clouds, causing them to contract and heat up. This process slowly transforms the chaotic cloud into a more organized structure, one that is dense enough to form new stars. Through this process of contraction, these nebulae can sometimes ignite nuclear fusion, marking the birth of a new star, continuing the cycle. One striking example of this phenomenon is the Crab Nebula, a well-known supernova remnant located about 6,500 light-years from Earth. The Crab Nebula was created by a supernova explosion recorded by astronomers in the year 1054. Today, It sits as a magnificent celestial canvas, where the elements scattered by this ancient explosion continue to interact and form new star systems. Within its vibrant filaments of gas and dust, one can observe the cycles of creation that have unfolded over the centuries, with new stars still forming amidst the remnants of their predecessors. As we reflect on these nebulae and supernovae, we see that the universe does not adhere to a simple linear progression. Instead, it operates through a dynamic and cyclical dance, where death gives rise to life and existence continually evolves and transforms. Each generation of stars pulls in the elements forged in the core of their ancestors, recycling them into new stellar forms. The cosmic fabric, rich with the residues of earlier life, continues to weave itself into intricate patterns, ever evolving. Furthermore, these nebulae also play a crucial role in shaping the larger structure of the universe. As new stars form within nebulae, they can ignite nuclear reactions, leading to even more supernovae. In this way, the energy of a newly born star can heat up its surrounding gas, driving shock waves that compress nearby molecular clouds. This can trigger further star formation, extending the cycle into realms of star clusters and potentially entire galaxies. The interconnectedness of these processes illustrates the grandiosity of the universe's recycling program. Surprisingly, the seeds of life as we know it trace their elemental origins back to these supernovae and the nebulae they create. Every atom in our bodies, carbon, oxygen, nitrogen, culled from the ashes of stars long gone. The cycle does not merely contain the birth of stars, it ultimately extends to the composition of planets, and importantly, to life itself. In this cosmic perspective, we see ourselves not as isolated entities, but as the products of a grand, continuous cycle of creation and destruction. The interplay between nebulae and supernovae reminds us of the fragile beauty of existence in the universe. We are intimately connected to these distant, fiery events, even if we don't often think about it. It is a poetic truth. From the violent death of one star arises the potential for thousands of new ones, along with the worlds they may harbor. Each segment of the cosmic journey is filled with echoes of past lives, reminding us that in the vast expanse of the universe, every ending can lead to an exhilarating new beginning. In contemplating this cycle of cosmic recycling, we are left with a profound appreciation for our place in the universe. As we gaze into the night sky, we are not simply looking at stars. We are perceiving the legacy of countless supernovae and the birthplaces of potential new stars. Each point of light holds a memory, a promise of what was and what may yet be. As we conclude this section, let us carry forward the knowledge that the universe is a living tapestry, woven from threads of creation, destruction, and rebirth, forever echoing the remarkable dance of existence. As we continue our journey through the cosmos, we arrive at the profound impact of supernovae on the formation and evolution of galaxies. These magnificent stellar explosions do not merely mark an endpoint. They serve as pivotal events that shape the very fabric of galaxies themselves. To grasp their significance, we must first consider the life cycle of a galaxy. Galaxies are vast collections of stars, gas, and dark matter, swirling through space in stunning structures. They are constantly changing, shaped by myriad processes, and supernovae are among the most powerful forces influencing this transformation. When a massive star reaches the end of its life, it explodes in a brilliant supernova, releasing an immense amount of energy, around 10 billion degrees Celsius at its core. This explosion ejects the star's outer layers at incredible speeds, sometimes exceeding 10,000 kilometers per second. As these materials plume outward, they create shock waves that ripple through the interstellar medium, the vast and largely empty space between stars. These shock waves are not just chaotic echoes of a stellar death. They compress nearby gas and dust, triggering a cascade of star formation within their wake. This process reveals the delicate dance of creation and destruction that defines the cosmos. When a supernova occurs in a galaxy, it can ignite nearby molecular clouds, the densest regions of a nebula filled with gas and dust, causing them to collapse under their own gravity and form new stars. This cyclical phenomenon can rejuvenate an aging galaxy, leading to bursts of star formation that can last for millions of years. Moreover, the materials expelled by supernovae enrich the surrounding space with heavy elements, such as carbon, oxygen, and iron, the building blocks of life as we know it. In fact, supernovae are responsible for producing about 95% of the elements in the universe that are heavier than helium. This enrichment is essential for galaxy evolution. Without the contributions of supernovae, the elemental makeup of galaxies would be profoundly different. The atoms created in the hearts of stars and scattered by these stellar explosions become the foundation of new stars, planets, and ultimately life itself. As we look at the structure of galaxies, we notice that supernovae can influence their morphology too. For instance, in spiral galaxies, where stunning arms of stars and gas are prominent, supernovae can compress the gas in these arms, fostering new star formation. The enhanced rates of new star births lead not only to the development of young star clusters, but also impact the dynamics of the galaxy, causing ripples that can affect its rotation and overall form. Additionally, galaxy clusters can be heavily influenced by the cumulative effects of numerous supernovae. In these vast groups, the energy released from multiple supernovae contributes to the hot gas that fills the space between galaxies. This hot gas plays a crucial role in maintaining the temperature and density of the cluster, allowing galaxies to coexist and flourish in the cosmic web of the universe. The interplay of galaxies, fueled by the remnants and byproducts of supernovae, strengthens the gravitational bonds that tether them together in these vast formations. When we consider the fate of our own Milky Way galaxy, supernovae have played, and will continue to play, a vital role. The last recorded supernova visible from Earth was in 1604, known as Kepler's supernova. It serves as a reminder of the past, but also as a harbinger of what will come. In the future, when our sun exhausts its nuclear fuel and transitions into a red giant, it will eventually shed its outer layers, creating a planetary nebula, while the remnants of its core could leave behind a white dwarf, another type of stellar remnant. While it won't go out in a supernova, it's this cycle of cosmic evolution that underscores the profound interconnectedness of all stars and the role of supernovae in shaping the universe. Against the backdrop of our universe, every galaxy we observe bears the fingerprints of countless supernovae. Their impacts mark a legacy of transformation, evolution, and resilience amidst the cosmos. By distributing essential elements and driving the cycles of star formation, supernovae weave the very fabric of galaxies, allowing them to evolve over billions of years. It is in this interplay of creation and destruction that our cosmic narrative unfolds. As we pause to reflect, we are left with a sense of awe at the complexity of the universe and our connection to it. The very elements in our bodies are remnants of ancient stars, sculpted and redistributed by the explosive artistry of supernovae. Each galaxy, a captivating testament to a history written in light and energy, invites us to keep looking up, to ponder our origins, and to consider our place in this vast, ever-evolving tapestry of existence. As we peer into the future of elements forged in the heart of supernovae, we step into a realm of speculation that sparks the imagination. The cosmic dance of matter and energy continues, shaping not only stellar landscapes, but the very building blocks of life itself. To understand this future, we must first acknowledge what supernovae send into space. A rich and diverse array of elements that are essential for the formation of stars, planets, and ultimately life. When a massive star explodes, it releases more than just a spectacular light show. It ejects heavier elements created during its life cycle. Elements like carbon, oxygen, and iron are spewed into the cosmic expanse, marking a significant contribution to the universe's chemical inventory. As these elements mix with interstellar gas and dust, they provide the raw materials for the next generation of stars and planetary bodies. This process will repeat across billions of years, creating a succession of stellar populations, each enriched by the materials recycled from their predecessors. Looking deeper into the future, one can envision how these recycled elements will influence the formation of new stars in distant galaxies. Over millions of years, regions that once hosted supernovae will cool down, and the remnants of these stellar explosions will coalesce once again, giving rise to new nebulae. Within these nebulae, gravity will pull in the stardust from the past, igniting new stellar nurseries. As stars ignite, they will fuse those heavy elements into even more complex structures, giving rise to new planets, moons, and possibly even life. Imagine a future where planets composed of iron and carbon orbit around stars that are themselves descendants of ancient supernovae. Some will host conditions suitable for life as they orbit within the habitable zones of their stars. Throughout the universe, countless worlds, each with unique environments, will gradually become laboratories of evolution, shaped not only by cosmic events, but by the elemental heritage passed down from their stellar ancestors. The interplay between supernovae and the formation of elements creates a vast tapestry of connections across the cosmos. Each supernova enriches its galactic neighborhood, and these enriched regions will join in a grand cycle of elemental evolution. The very building blocks that make up proteins, DNA, and even the air we breathe, everything necessary for life, can be traced back through the cosmic lineage to supernova explosions. However, the fate of these elements doesn't end with the birth of new stars. As stars age, they too will contribute to this cycle, expelling their own elements back into the universe at the end of their life cycles. This continuous flow ensures that the universe remains dynamic, rich in diversity, and capable of fostering new forms of life. With time, we may witness not just repeats of past processes, but unique combinations of elements and conditions that could lead to different forms of life than we know today. As we gaze into the night sky, we are actually looking into the distant past, witnessing an ever-evolving universe filled with potential. The future of elements, shaped by the explosive death of stars, weaves a narrative of endless possibility. Each seed of these elements, sown throughout the cosmos, carries the promise of life and complexity, bound together by the mythic cycles of creation and destruction. The vast stretches of space are not just empty voids, they are filled with the echoes of these cosmic events, whispering promises of new worlds and new beginning. While we cannot predict exactly what will emerge from this galactic garden, we can marvel at the concept of a universe that is alive, continually adapting and evolving, shaped by the elements born from the ashes of stars. In this grand cosmic context, we find a poetic truth. Our existence is inherently linked to these processes. Everything we know and everything we are is intrinsically bound to the universe's rhythms. The supernovae of ancient stars are not merely historical footnotes. They are active agents in the ongoing saga of existence. Like stardust scattered across the cosmos, we carry within us the history of stars, the essence of the universe that connects us all. Looking forward, will we someday witness the birth of new intelligences emerging on distant worlds? Or will they tell stories of their cosmic lineage, tracing their own origins back to stellar explosions that occurred billions of light years away? The possibilities are as boundless as the universe itself, filled with mysteries yet to unfold as supernovae continue to play their vital role in shaping the fabric of existence. In a universe that is perpetually restless and in motion, one thing remains certain. The elements born from the breathtaking violence of supernovae will forever mold the future landscape of the cosmos, nurturing life in forms both familiar and astonishing. As we reach the conclusion of our exploration into the dance of nebulae and supernovae, it is important to take a moment to reflect on the profound beauty and interconnectedness of the universe. Each of these magnificent celestial formations tells a story, woven into the very fabric of existence. Nebulae, those luminous clouds of gas and dust, serve as the cradle of stars, where raw materials gather and fusion ignites, giving birth to blazing suns and the planets that may cradle life. But this journey does not conclude with the birth of stars. Just as each star rises to illuminate the cosmos, it is destined to play a vital role in an even grander cycle of life and death. When massive stars exhaust their fuel, they culminate in a breathtaking finale, a supernova. This cataclysmic explosion not only serves as an end, but also as a beginning, casting elements forged in stellar interiors throughout the cosmos, elements that we now recognize as the building blocks of planets, life, and even ourselves. Imagine for a moment the vastness of space. Supernovae rip through it like fireworks, dazzling displays of energy and color. When a supernova occurs in a galaxy, it can outshine entire galaxies for a brief moment, reminding us of the power embedded within these processes. In that fleeting moment, they seed the cosmos with the heavy metals necessary for forming planets capable of supporting life. Iron, carbon, nitrogen, elements essential for our existence, are all products of this stellar alchemy. When we gaze up at the night sky, the stars are not merely points of light. They are echoes of ancient explosions, remnants of long-dead stars that once shaped the universe as we know it. The very atoms that compose our bodies originated in the hearts of stars that lived and died long before our solar system took form. What a humbling thought, to be made of stardust, a testament to the interconnectedness of all things. The very act of understanding these cosmic forces connects us deeper to our universe. With every new discovery of distant supernovae or the spectroscopic analysis of nebulae, we unravel bits of the history of our universe. Each observation tells us more about the evolution of galaxies, the birth of stars, and our place in this cosmic narrative. This is not just a story of chaos and destruction. Rather, it is one of renewal and hope, showing how life emerges from the remains of what once was. As we sit in contemplation, one cannot help but feel a sense of reverence for the cosmos. In the history of the universe, spanning over 13 billion years, the intricate processes that govern its evolution invoke a sense of wonder. The cycles of creation and rebirth not only shape the heavens above, but also reflect our own journeys through life. In the vastness of time and space, we discover a powerful truth, that we are all part of the same cosmic tapestry, each one of us linked by the remnants of stars. In closing, as you ponder the enormity of the universe and your place within it, remember the dance of nebulae and supernovae, a reminder of how beauty is birthed from destruction, and how every element in our bodies has traveled through starry nurseries and fiery remnants. Embrace the interconnectedness of existence, for it speaks to the shared nature of all life and the continuing story of the cosmos. If you found this journey enlightening, we invite you to follow our channel for more explorations into the wonders of the universe. Like this video, so we can continue to share the beauty of science with you. Together, let us journey through the stars, seeking knowledge and comfort in the shared narrative of our existence among these celestial